Welcome to week 8 of our C++ video series. We're going to wrap up this series by taking a closer look at iterators and getting familiar with some of the algorithms provided by the standard library. We mentioned iterators briefly when introducing the standard library containers. Iterators provide an abstraction for ranges of data, such as those in a container. This abstraction makes it easier for us to write generic code and algorithms which work with broad categories of containers or data sources. An individual iterator is a handle pointing to a specific location in a container. We can move an iterator around and we can use it to get the element at that spot of the container. If you're thinking that this sounds a lot like a pointer, you're right. There's a good amount of overlap in the behavior of iterators and pointers. In some situations, pointers can be used as iterator types. But it's important to recognize that iterators provide a broader set of capabilities than raw pointers. There are iterator types that can do things which pointers can't do. Iterators in the standard library are divided into 6 different categories. Each category defines a set of functionality which an iterator type must provide to be considered part of that category. Individual features include things like the ability to read or modify values, the ability to move backwards through the container or jump to arbitrary locations, or the ability to make multiple passes through a container. We won't review each category right now, but know that when you see the documentation for some algorithm that says it requires, for example, bidirectional iterators, you can check the definition for this category to see what functionality needs to be provided. Now, how do we get iterators from a container? Well, that's often done with 2 functions, begin and end. The begin function returns an iterator pointing to the first element in the container, and the end function points to an imaginary location 1 space after the last element in the container. This follows the pattern more generally used to represent a range with iterators. The first iterator points to the start of the range, and the last iterator points 1 after the end of the range. You'll see plenty of code that wants to work with a generic range of elements. This code will usually take a pair of iterators to represent this range. Some containers also provide additional functions for getting specific kinds of iterators to their contents. For example, cbegin and cend will give you read-only iterators into the container. rbegin and rend will give you reverse iterators, which will take you through the container backwards. Here's an example of using iterators to step through a vector. We initialize an iterator into the vector by calling begin. Then we loop until our current iterator is equal to our end iterator. At the end of the loop body, we use the increment operator to move our iterator to the next element in the container. At each location, we can dereference the iterator to get a reference to the current element. We can modify the value, like we do here by adding 10, or we can read the value, like we do here when we're printing it to the console. Iterators don't have to be simple handles to existing spots in containers. The standard library provides a diverse set of iterator types that do more interesting things, and you can always provide your own. Most of these types are defined in the iterator header. One such iterator type that pops up a lot are inserters. These are special iterator types which insert new elements into a container. Perhaps the most commonly used inserter is the back inserter. To construct a new back inserter, we give it a reference to the container we want to append to. Every time we write a value to this iterator by dereferencing and assigning to it, that iterator will append our value to the end of the container. So, in this example, we're looping from 0 to 9 and appending each number to the vector v. When that loop is done, we can see all 10 values have now been added to our vector. There are other iterator types that do useful things, including stream iterators for reading and writing to standard input and output streams through an iterator interface. There are also other utilities that are helpful when working with iterators, such as stood_distance, which tells you how far apart 2 iterators in the same container are. You can see documentation about all of these utilities on the Iterator library page of cppreference.com.